As always, the recording will be put on the YouTube channel after this. So if you're watching this after the fact, feel free to ask us questions in the Slack or by email. But yeah, we'll go ahead and get started. So let's see. So today we're going to be getting into the Asteroid Smasher game in Python. And this is the game that everybody will be creating AI agents for to be able to play. Okay, well, PowerPoint's not cooperating. Anyway, so some general info. This is our website, and registration is still open. If you go to the website, you can click register here. We're likely to keep registration open through at least all of September, maybe even longer than that. We're still looking for more teams to join. So if you're watching this and you haven't joined the competition yet, please go ahead and sign up by going to this registration link on the website. There's all sorts of other information on the website. There's general information about previous years, how to get started, things like that. There's frequently asked questions, the rules, and most importantly, the schedule. So we have the schedule here on this page. This is subject to change, but a lot of these things are either already decided or they are, the general timeframes are decided. Like we have a few seminars that'll be in October that we haven't decided the exact dates for, but we'll be figuring those out soon. So check back often. We'll also put out announcements both through email to the people who have registered and in the Slack. I'm gonna mention Slack yet again because that is our primary method for communication with the teams. So please, if you're planning to compete, join the Slack at this site, and you should be able to join. We also have our YouTube channel. If you go here, there will be all of the seminars from this year, as well as the seminars from previous years, and additionally, the competitions themselves. So you can go see information from previous years. You can go see the competition results and see how people did, that sort of thing. There's a lot of useful information. We've already talked about the students per team, but today we're going to go into a bit more into Python to actually get started. So Asteroid Smasher is a Python arcade game. You can go to this site and see the original game that was made. It's really just used as an example for how to use Python Arcade, which is a package that allows you to construct your own video games using Python. This is a modified version, so it's not the version you'll find here. It is a modified version that we host in our own repo on GitHub, and it's called Fuzzy Asteroids. And in fact, we actually have releases for it, and it's on PyPy, so you can just pip install it, and it'll go grab the latest release version on PyPy. And actually, if we go there right now, maybe. We can look up Fuzzy Asteroids and get the description and see the release history and all that good stuff. And so that's all you need to do is pip install it and you're ready to go. You're ready to use it, I should say. Yes, this is the version you'll be using. I will go ahead and let you know that there will be an updated version of this in the future before this competition is over for this year. But the current release version that you'll install is sufficient for now because we're just going to be learning how to do the basics. Again, Asteroid Smasher is a game where you have a ship that is trying to avoid and shoot asteroids. You get points for all of the asteroids that you hit, and when you do hit an asteroid with a bullet, it splits into a number of smaller asteroids. It does this in a certain random way, and then they also have initial velocities and all these other things. Once you hit the smallest asteroid pieces, though, they disappear. And all of these count for the same amount of score, and you have a certain number of lives that you for the ship. So anytime the ship gets hit by an asteroid piece, that takes a life. Of course, we want to train controllers to do this automatically, so that's where machine learning, fuzzy, all that good stuff comes in. Yeah, points scored by remaining alive and hitting asteroids, pretty self-explanatory. This can be modified by you during the machine learning process. We'll get into that, and I'll show you where you might be able to do some of that. The final scoring criteria typically just involves asteroids destroyed. This may be a bit different this year, but we'll let you know what that will be exactly by the time we do the competition introduction after the other seminars. That'll be in late October, early November, if I remember the schedule correctly. The final scoring criteria may include other things. In the past, what we've done is it's been the number of asteroids destroyed, and then tiebreakers based on accuracy and computational efficiency. We will likely keep the same sort of thing this year. We do also have an overall score that gets attributed to your explainability, but we'll talk about that at competition time. It's not really relevant to the machine learning aspect or the scoring aspect for learning processes. Any state information available with the environment can be used. So you can use things like the vehicle positions and velocity, the asteroid positions and velocity, projectiles fired, etc. There's more information that you can use. I'll show you what those are. You can also generate your own things. You can create your own metrics and use that information to do whatever you want. Certain people have done things like threat prioritization. You might want to do something like path planning. You might want to make a density map for asteroids. Anything like that is completely fine. So the repositories that you'll need to know about, the environment is the fuzzy asteroids environment. So this is the modified version of the Asteroid Smasher game. This is hosted on this repo. So it's github.com/xfuzzycomp/fuzzy asteroids. And so we can go there. This is that repo. And you can go, this is all open source. You can go look at all the code. You can see into the environment, all that good stuff. They're always read the README because it tells you how to install. Also, if we do an upgrade of the environment, if we put out a new release, we'll let you know, but you will have to upgrade it using pip. But we'll cross that bridge when we get to it. You will need to use versions greater than or equal to 2.0.0. Right now, we're on 2.2.1. I believe that's the current version. Yes, 2.2.1. If you go to releases, you can see the previous versions that were released. But 2.2.1 is the latest. It has all the functionality. It also tells you certain things that were changed. We will be putting out another one before too long, but again, we will let you know when that happens, and it's not going to change things fundamentally for what we're showing today. So just go ahead and pip install the latest, which if you run this command, that's what it'll do. We do also have a template repo, and so you can go to this github.com/xfuzzycomp fuzzy asteroids example. And what you can do, and let's get in the way. So this is the fuzzy asteroids example repo. And this is a template such that if you click on use this template, you can generate your own repository from it. So my fuzzy asteroids repository. And you can create this, and it will create a repository using this template. And if you do that, you will get something like this. So I'm showing you all the files actually in PyCharm in the actual development environment. But this is, I use that template to create a repo. And these are the files that you get. So it has a README, it has the requirements, all of these things, and a bunch of example code. So First thing we're going to do, though, is go back and go to the remain, because that's what we should do. So getting started, make sure you have Python and make sure it's on the system path. If you don't know what this means, there's a lot of information out there on how to do this. You can also ping us if you're having trouble getting Python set up. You also will need Git. We are going to require that you have your own repository, either on GitHub or elsewhere. We highly recommend GitHub or GitLab or some other free repository management service like those. Make sure to have your preferred development environment. We don't specify any of that. If you want recommendations, we can make recommendations, but it's really up to you. Make sure to connect to Git with and Python with your IDE. This can be very different depending on what you're doing. If you're using something like we do, like PyCharm, which is a particular IDE, that's the one I just showed. This is very easy to do, and it's typically pretty easy to do with most other development environments. But if you run into trouble, ping us and we can probably get you pointed in the right direction, even if we don't have experience with it. So this repository being a template means you can easily just copy all this stuff to your own repository and get going. After configuring your repository, you clone it with Git. You can either do it, with command line options. You can use some sort of GUI-based tool. We haven't used one called SourceTree, but there's a bunch of other ones out there, including like GitKraken, or even there are others. There's quite a few. Also, make sure the first thing you should do after doing this is to install the requirements. So this will, through pip, install all the dependencies that you need to run the game. And after that, you should be good to go. If and when you need to update it to a new version of the game, there's a couple of different options. One, you can upgrade all of your requirements just to make sure everything's up to date. You can also just upgrade the game itself. Again, if you're having issues with this, sometimes you also need to add a flag to force reinstall, just to make sure that it grabs the latest version that's on PyPy. But that's pretty it. It's pretty straightforward to get this template up and going. And once you do that, you're able to start doing things. So first things that you're going to be doing is making a class called Fuzzy Controller. Now this, I'll just go ahead and go to the code base. So this doesn't exist in the code that you'll have. The code that you'll have will look something like this. So let's go ahead and look at Run Game Controller. So this is a script that's set up where we are setting a bunch of settings for the environment for the simulation. We're creating a game object using Fuzzy Asteroid Game. That's where all of the game information is held. We're passing it those settings. We are doing a few other things like tracking our computation cost. Our controller can time out. We're not going to ignore exceptions. We're also creating a scenario. So you can create custom scenarios too. Well, I'll show you a bit more about that in a little bit. In this case, we're making one that we're naming multi-ship. It has 4 asteroids that are assigned random positions. You can also put the asteroids in whatever position, initial state that you want. You'll see a number of different ones of those at the competition. And also the ship states. So the ship states this is just the initial values for your ships. So in this case, we have 3 ships. This is just a list of dictionaries where the dictionary has information about the ship's initial position, the initial angle, and the lives. Typically, you won't be setting the lives value. We tend to restrict those to the default. But if you're doing something specific in training, these are all options you're allowed to change. And then after that, we are running the game with the controller that we make and that scenario, the scenario that we made right here. However, this is not defined currently. And so what we can do is make a controller and so this will be the controller class where we actually define what your AI agent will be doing. I'm actually going to switch back over to a previous example that was made just to show you what that might look like. So this is our fuzzy controller class, which doesn't necessarily need to be named this. Sorry, it does need to be named that currently, but we may be changing this in the near future. Again, we'll let you know about any changes. However, it must inherit from controller base. Controller base is the that base controller class. There's certain things you'll need to define, like the name for your controller. So this is, in this case, it's a property, and you just define this string that is a controller name. You also need to define this function called actions, and actions simply describes what your agent will be doing. The information that you get in are the ship information. This is a list of the ship objects, and then also the input data. This is data coming from the environment about. It includes things like the map, the simulation conditions, the objects that exist in the map, like bullets and asteroids and things like that. In fact, let's go back to the presentation because we'll see some of this. Before I show you the data though, ships, the main things that you'll be affecting, there are many other properties that the ships have. However, the main things that you are controlling are their turn rates. This is how quickly they are turning. Their thrust values. This is the amount of thrust both forwards and backwards that you're assigning, and whether to fire a bullet or not. So if this is a Boolean, and so if that's set to true, that particular ship will fire a bullet during that simulation time step. This input data is a dictionary, and it includes a bunch of different information. Let's see, what else? Oh, you do need to define the init method. This is just for initialization of your controller class. Again, you must have the actions function defined. This is where we pull all of, the command outputs from your controller and send them back to the environment. Let's go to the next thing. So input data, what this actually looks like, this is a dictionary, and these are the keys for that dictionary. So you have things like the frame. This is the frame of the simulation time, the stopping condition. If it's in the middle of the simulation, this is typically set to none, but there's a number of different stopping conditions, like there's no asteroids left, there are no lives left, or you ran out of time. You can also get the map dimensions if you need those for doing certain calculations. You can get all the information about the asteroids. The information that's included in the asteroids data this is actually what is included in that. Our frequency, this comes from the sim environment. You typically don't need to worry about that. The position for each asteroid, the velocity for each asteroid, the size of each asteroid. This is an integer. If I remember correctly, just from 1 to 4, there's only, I believe, 4 different sizes of asteroids. And angle, this is the angle of the velocity vector with respect to the reference frame, the global frame. There are also these state information values for the bullets. It looks very similar to this, though. You can access them in the same way through the input data dictionary by going to bullets, and then you can access things like position, velocity. Bullets also have a thing called bullet speed, but that's just a hard-coded value. So that's some of the information you can access. And so what you can do, I'm going to go back to the code real quick. You can see in this example that we are taking in input data and our list of ships, well, in this case, a tuple of ships. We're doing some sort of function on the input data. In this case, it's just a timeout. We're just waiting for an amount of time for some reason. But there might be some other functionality we have, like, you know, some other do thing to input data, or calculate something based on input data. And then at the very end, after you do all your calculations or whatever else you're going to do, you then assign turn rates, thrust, and bullet firings to each of your ships. And that's pretty much it. Now, in input data, let's say you wanted to get information about the asteroids. You may have something that looks like this, where you say asteroids equals input data, asteroids. And then you can say for asteroid and asteroids, you know, something, calculate something based on the position. So you may have something like asteroid, I forget what they're called, asteroid position. And then assign that to something or make some sort of calculation based on that. But you can do the same thing for the bullets, the map dimensions, all that stuff. So remember, you're referencing that dictionary that is input data, and then from that, accessing that information for each object. Okay. I'm going to go back to the other example. So this is the code that was created by using the template repo. So it doesn't have anything defined. We don't have our actions defined or anything like that. So you'll need to do that. But then after you define your controller to actually run the game, you just simply do what's here in run game controller, where you're setting up the game with your settings. You define a scenario. In this case, we're defining this scenario ship with all of these attributes. You can also define other scenarios. In this case, we have an example scenario where we have a bunch of asteroids creating basically a wall. So these are asteroids at all these positions, starting off just moving relatively slowly. We also have ones where you have multiple ships. You may only have one ship. You can take a look at all these example scenarios. And then what you can do is you can create what we call a portfolio. This is just a list of all of these scenarios. And then you can do things like train your AI agent over those different scenarios. So you can make sure that it has good coverage in the training space. You can put it in particular situations if you needed to learn certain behaviors, etc. And then you can run these like we saw here. And so you can run the game with a specified controller and with specified scenarios. In this case, it's just the single scenario, but you can also modify it to be multiple. Let's also look at an example score. So this is a class that we're defining called sample score, which inherits from the main score class that is held in the fuzzy asteroids utilities. And you can go take a look at it. The main fuzzy score. Okay, I don't know why it doesn't want to open. Well, that's okay. We're just going to look at the example score. You can modify this, though, by defining how the score changes every time step, and then also what the final update for the score is. And so in this example, we're simply looking at the number of asteroids. So this is the length of the asteroid list. And we're calculating this to determine the number of asteroids that are active. And then on the final update, we're doing something else where we're taking the number of asteroids at the very last time step, dividing that by the number of frames. And so we're getting the average number of asteroids over time. Or sorry, yeah, the average number depending on the simulation time. But you can modify this to be any other score that you would like in order to do training. Just know that the score will be, for the final competition, will likely only be the number of asteroids. That may or may not be a good scoring criteria to do machine learning with, but we will leave that to you. Obviously, you can ask us whatever you like about modifying the score and what you should do, but that won't affect the score during the competition. Another thing I want to point out is run training. So there is also a training environment. This is just a modified, it inherits from the Fuzzy Asteroids game, which is held here. But you can use this in order to do your machine learning training. And so this is just a small example of what that might look like, where you have settings. You can take a look at what those settings look like in the trainer environment. In fact, if we go back to the environment itself, let's go down to that trainer environment. So this inherits from Fuzzy Asteroid game. So it'll be similar. It'll have a lot of the same properties, but we also have, we extend that with a few other things, including things like turning the graphics off, turning the sound on and off, various prints, allowing key presses, and dashboard. This is a bunch of other information that gets printed on the screen when the game is playing. Yeah, we're calling the constructor for Fuzzy Asteroid game. And so if we go back to that run training example, we construct the game using that trainer environment. And then what we can do is run through our whatever iterative machine learning process we have. In this case, nothing's really happening. We're just running through and getting the score. But in this case, we're running through and getting the score using this controller that is defined somewhere. A score that we're defining, because we're importing that from our example score. And the output of running the game is actually, it will return that score value from sample score. If you're using something like a genetic algorithm, this is similar to what it'll look like, where each one of these loop runs is, each one of these loops is a generation. And so you're getting the score back, and then you're doing other operations within here, your mutation and crossover and all those things. This may look a little bit different depending on the machine learning process that you're using. Again, you can ask us. We may or may not be able to give you all the information depending on what you're trying to do specifically. However, we should be able to point you in the right direction based on what to do with interacting with the environment and what you can get back. I do want to also go back to, let's see. I'll go back to the main environment. There is also a scenario runner, which is in Fuzzy Asteroids runner. And this allows you to run through multiple scenarios at the same time. So you can create portfolios. You set this up just like you would a game with your controller and your portfolio, which is just a list of scenarios. And then you can run that with with your controller over all those scenarios. So that is one way you can do that, to train your agent over multiple scenarios. So Now I'm going to go back to the presentation. One thing we have highlighted throughout the course of the competition in previous years is that open source is a focus of this competition. So all of the environment code is open source. We encourage open source because of collaboration and trust in we're developing. There are some past competitor repos that are open source. We'll have to ask the previous competitors if they are okay with sharing that, but if so, we will share that with the teams that are competing this year. However, we do recommend keeping your own repositories private until competition day to prevent accidental collaboration, just to make sure. That said, though, I'm then going to move on to the first milestone. These are optional milestones, but they are really a good way to make sure that you're staying on track. So really, the first one is just a hello world in Asteroid Smasher. So this is quote unquote due. There's no deliverable. You don't have to send anything to us, but this is a good date for when you should be able to do all of this. Using the example repo template, which we already saw, make your own repo, follow the README instructions. If you have trouble, please ask us. Familiarize yourself with the structure, where everything's being pulled in, what you need to define. Remember, you're pretty much mainly working with that fuzzy controller class, and then creating a game and running it with that controller class. Familiarize yourself with what you're getting in and out, what other information and calculations you might need to create within that class. It doesn't necessarily need to be within that class, but that class will need to access it. And so what you'll need to do is modify the control actions of the agents. So you don't have to use fuzzy, you don't have to use any sort of AI or other machine learning thing. You can just make it by hand. You can make it as complicated or not as you want, but what you should be able to do is make the agent move. So it needs to modify its turn rate and its thrust. And then also modify its shooting. So at some point it shoots a bullet or multiple. And then also experiment with using the information that's getting in that input data dictionary to calculate something. Maybe you calculate something like the centroid of all of the asteroids, or maybe you use it to calculate the centroid of all of the biggest asteroids. So maybe you only calculate the centroid if the asteroid size is the largest, something like that. Just use that information and calculate something based on it, just to make sure you're able to do that for your actual system. Again, let us know if you're having trouble. We're happy to help. But again, go through the README to get everything set up. And then it should be relatively straightforward. Also, if you go back and look at the examples that we have here with defining your fuzzy controller and defining some actions for it to do. That's really all we're talking about. So with that, I will take any questions that anybody has. All right, well, I guess since we only have one person live, I will leave it open for another couple minutes, but then we'll cut it off and I will make sure to put this on YouTube. If anybody's watching this after the fact and has questions, please join the Slack. You can also email us. This is our contact info. Sam King for general competition questions, myself for milestones, deliverables, seminars, and also Lynn Pickering for general code and fuzzy toolbox questions. But really, any of us, you can ping any of us and we'll get back to you. All right. Well, since we don't have any questions at the moment, I'm going to go ahead and stop the meeting for today. Again, please reach out if you're having issues and work through the milestone to get familiar with the code, play with the game a little bit. That'll really help you get a head start on developing your agent. All right. Well, with that, thanks for joining, and we'll talk to everybody soon. Cheers.